Okay, good evening. Welcome to
MinuteMath141.
MinuteMath141. Today we have a super cool problem from the Mathematical Association of America's MinuteMath page. It's a probability problem from the 2000 AMC8. And only 8% of the people taking the test got this right. So this is a very challenging problem. Are you ready?
Yeah.
Kaiko tosses 1 penny and Ephraim tosses 2. What is the probability that they get the same number of heads?
Well, probability is the number of good outcomes over the number of total outcomes.
Okay, very good. So let's write that. Number of good outcomes over the number
Of total.
of total.
Well, we only have one good outcome.
What is that good outcome?
It's where, well, actually, is when Kaiko gets a head, and is head tail the same as tail head?
What do you think? He's tossing 2 pennies. Are those the same outcome? Head, tail, and tail head?
No,
Why not?
because it's different pennies.
It's different pennies.
So actually, there's two. We could have Kaiko gets a head, and these 2 outcomes. So we get the same number of heads. So it's going to be 2 over the number of total outcomes.
Okay, well let's look at the total outcomes and see what that looks like.
You mean Kaiko's total added with Ephraim's total?
Well, we have to figure out all the total number of different outcomes, and so maybe we should make a chart. Maybe I'll erase number of good outcomes and number of total outcomes. So we have Kaiko, who's only tossing 1 coin, and Ephraim tossing coin 1 and coin 2. Okay?
Mm-hmm.
I'm not making the best chart, but... Okay. What are the possibilities when Kaiko tosses the coin?
Well, if Kaiko can get a head or a tail.
Kaiko can get a head or a tail, and what can Ephraim get?
Well, for every one, Ephraim could get a tail and a head, or a tail and a head, 2 heads, a head and a tail, or 2 tails.
Ah, interesting. So let's talk Ephraim here. He can get tail, 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 head, head, tail,
Head, head.
head, head, and Kaiko.
Head, head.
Oh, I'm sorry. Good catch. Head, head. And Kaiko could get a tail for each one of these times, right?
Yeah.
Or Kaiko could get a head for each one of these times, too. Oh, can you run and check if I'm on camera still here? Right down here?
Yeah.
Okay, thanks. Okay. So here's the total outcomes. There's 4 different outcomes that Ephraim can get. Tail, 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 head, tail, head, head.
Mm-hmm.
And for each one of those outcomes, Kaiko can get a tail or a head. Okay. Now we should just check real quick. So there's 8 total outcomes. But based on what you did initially, it would be 2 over 8, right?
Yeah.
But let's just double check. Let's go through these and see when Kaiko has the same number of heads as Ephraim.
Well,
Okay.
not going to be any of these,
Why not?
because Kaiko doesn't even get a head.
Okay. How many heads does he have?
He has 0 heads.
Okay. Does Ephraim ever have 0 heads?
Only here.
So does that count?
Yeah, I think it does.
Ah, so
It's sneaky.
there's one of the sneaky tricks in the problem. In this case here, actually, can you let's circle it with brown. In this case here, they have the same number of heads, which is
0.
0. So Kaiko can get no heads or 1 head. In this case, no heads. Now, what about in the case where he has 1 head? Why don't you circle the cases that work?
This case, in this case. Oh wait, no, not that case.
Not this case, okay.
Because it's got 2 heads.
So how many total cases work?
3 total cases out of 8.
Out of 8. Okay. Challenging problem, right?
Yeah.
So the interesting thing is, this only has 2 people flipping coins, and they're only flipping 3 total coins, right?
Yeah.
So even there, it gets pretty tricky. You just want to write down all the cases, and then figure out how many work. And don't make assumptions. Having no heads, you still can have the same number of heads, because 0 is a number, right?
Yeah.
Good job. Good job. That's a fun problem. Probability is a fun subject.